Welcome to the EASTEC show. My name is Werner Lueken. I manage the tool inspection department at ZOLLER. This year we celebrate our 80th birthday. Here's our genius 5-axis tool inspection machine. See, we got Z-axis, Y, there's a B-axis right here, and the C-axis. And I'm going to load the tool here. It's a hydraulic chuck. I just press the button and it clamps it. Improvements over the previous model are also that we have a door here that goes up and down. In here we got holders for the collets as well as for the adapters and tool posts. Software wise, it's extremely easy to program this tool. In here, it's very much conversational what I want to measure. See the core diameter, the rake angle, circumference. So basically I just pick helix, in this case a margin width because of the drill, and view. See, I can do multiple alignments, especially on drills, and then I can measure my relief angles, land width. Everything is very conversational. The purpose of the machine is really to enable anybody to walk up, stick the tool in, and start the program. So it'll provide user-independent measurement. Basically, here we see the 2D camera, basically lining the fluid up, and it will hand over to the 3D camera over there. And then you'll see the succession of the parameters that will be measured. Right now here we have the helix angle. It'll indicate the flute, the cutting edge. We measure basically a portion of the lead angle, which brings us the helix angle. So here we have a measurement where the machine basically recognizes a contour between dark and bright. Same here. So we create a scenario with the light segments where we have a bright margin, dark relief. See here, automatically puts a line there for the margin. Here we have our first 3D measurement. It just rotated to the rake face. You can see how the focus pixels rush through the window here. We recognize every pixel, and that creates a 3D point cloud. That point cloud we can analyze. We section it any way you want. Core diameter, same thing with. You can see we'll find the deepest spot in the flute. We measure the flute depth, diameter minus twice the flute depth is the core diameter. That also would give us flute taper, for example. See, now it actually, the camera will swing it down. We can see the axial view. First thing is going to give us a head of center. At the same time, it will align the flute. There we go. Now we basically do a 3D scan in axial direction. You can see the scan here. Important to understand is we're looking, of course, at a point angle, at a clearance on the point angle. We will still measure the normal clearance, meaning through mathematics, we will get the perpendicular section. Land width is again a contrast measurement where we create a dark and bright contrast. This is what we call a depth image. Obviously, we need to stitch the picture together to get a whole understanding of the clearance. See, it turns back. The outcome of the whole thing is we have a certified report right here. Print it. There we go. You can see parameters, nominal, tolerance, and axial value. There you have it.